Alright, here we are with Unit 11, Lesson number 3, and we're going to get into in more detail now the different kinds of hydrocarbons, which we had mentioned earlier, alkanes, alkenes, alkynes. This is Table Q from your reference tables, and we're going to discuss that and Table P, so make sure that you have your reference tables out, although you don't really need to because they're already in the notes. A couple of things are going to have you, if you have your reference tables, you might want to write this in here also on your reference tables, but that's up to you. A couple of things to remind you about is that alkanes are what we call saturated, and both of these are unsaturated, and I'll explain why that's going to be important later on. Also, what I want you to remember is notice how this is an example of an alkane. Notice how it ends in A-N-E, same as the type of hydrocarbon. These all end in E-N-E alkenes, and alkynes all end in Y-N-E. Okay? And that's going to be important because if I give you the name of a compound, you have to be able to tell me if it's an alkane, alkene, or alkyne, or if it's saturated or unsaturated. So you need to know that. Second is the general formula. Obviously, it doesn't have to be memorized because they're here, but you do need to know how to use it. Now, how would you use these? Well, if I came up with a compound, let's say I gave you this compound, C4H8, and I asked you, is it an alkane, alkene, or alkyne? How would you know that? Well, the way you would do that is by using the general formulas. And the way you would use it is that the N is the number of carbon atoms. So what you would do is in each of these, right, you're going to plug 4 in for N. So N equals 4. So you have CnH2n plus 2. If I plug 4 in here, I'm going to get C4. And then I have 2n, which would be, of course, 4 times 2 is 8, plus 2 is 10. Well, that's not the formula I was given. So you know that this is not an alkane, right? Let's try the next one. Next one is CnH2n. And I gave you C4H8, right? If I plug 4 in here, I get C4. And if I plug 2 in here, 4 times 2 is 8. So I know that this is an alkene. It is also unsaturated. So if I give you a hydrocarbon, the molecular formula of a hydrocarbon, you should be able to tell me if it's an alkane, alkene, alkyne, or if it's saturated or unsaturated. Okay? Don't get caught up in the homologous series. That's just telling you that all alkanes have a few things in common, right? They're all alkanes. They all have the same general formula. They all have single bonds, etc. You don't necessarily even need to worry about that term on the Regents exam. A couple of things to make note of that you should definitely, and we talked about this before, is that there's always 4 bonds around every carbon, and H's only have 1 bond around it. Okay? Need to keep that in mind. We're going to run into other elements that we're going to go through, like, for example, oxygen always has to have 2 bonds around it, chlorine always has 1, etc. Let's go on to the next table, reference table P. Reference table P is needed because it tells you how to name, or it gives you an idea of how to name organic compounds that are alkanes, alkenes, alkynes. It really only tells you about the prefixes, which is the first part. So basically, any hydrocarbon, whether it's saturated or unsaturated, is named first using these prefixes. The prefix only tells you how many carbon atoms you have. That's pretty much all it tells you. So for example, if you look at this here, C3H8, first thing you're going to do is you say, okay, it has 3 carbons. So I know it's going to begin with prop. What I don't know is if it's an alkane, an alkene, or alkyne. So I take this and I go back to the formulas that were at the top, and it turns out that this matches this general formula. If you plug 3 in here, you're going to get C3. If I plug 3 in here, 3 times 2 is 6, plus 2 is 8. It's an alkane, which means it ends in A-N-E. That is simply propane. It is the gas that you use in your barbecue grills. Number 2, now they've given you the name. It's prop, so you know it begins with with 3 carbons. Notice it ends in YNE, so it is an alkyne. Here's the formula for alkynes. CnH2n minus 2. I gotta get rid of this, it's too big. Okay, let's try it again. So it's propyne, so it begins with 3 carbons. I know it is an alkyne with a Y. So I look at the formula, it's CnH2n minus 2. I plug 3 in here, I get 3 times 2 is 6, minus 2 is 4. So the formula is C3H4. Next one is C4H8. It has 4 carbons, so it begins with bute. I don't know if it's an alkane, alkene, or alkyne. It turns out that C4H8 matches this general formula. If I 2N. If I plug 4 in here, I get C4, and then 4 times 2 is 8, so it's an alkene, so I know it is butene. Again, I notice this is an alkene, right? I notice that it has 5, pent is 5 carbons. If I plug 5 in for the alkene, right, 5 times 2 is 10, so I know it's going to be C5H10. Next one is C6H10. I know it's not an alkene because it doesn't have twice as many hydrogens as carbons. And I know it begins with 6, so it's going to begin with hex. So it matches, I believe it's going to match the alkyne with a Y, which is this one here. So if I plug 6 in here, 6 times 2 is 12, minus 2 is 10. So it's an alkyne with a Y, so it's hexine. Hexane is 6 carbons. And it ends with ane, so I know it's an alkane, which is, sorry about that, I haven't been able to figure out what's wrong with it. So I know that this is going to have 6 carbons. I plug it in for the alkanes because it ends in ane. It's CnH2n plus 2. I plug, it's not 6, it's C6, right? Look like 8. I plug 6 in. 6 times 2 is 12, plus 2 is 14. And that's the molecular formula for hexane. And that's how you use tables Q and P. Okay? And that is the end of this lesson.